Series circuits. Basically, we divide series circuits as RL series circuit, RC series circuit, and RLC series circuit, where R is the combination of inductor, R is the combination of capacitor, or is the combination of both inductor and capacitor. Here we will be getting R as well as the inductance reactance XL, here XC, and here XL, XC. When these circuits subjected to AC supply, the currents in the circuit and all the voltages across the elements are sinusoidal. Now let us find out the voltages, that Vs equals to R I of t plus J XL I of t. For this, Vs equals to R I of t minus J XC I of s. This V of s equals to R I of t plus J XL minus XC I of t, where XL equals to omega L, XC equals to omega CE 1 by, and here both the combinations. Now in the resistor, both voltage across the resistor and the current I are in phase. In all the cases, the phase angle is 0 between these two. Since this is series circuit, currents will be same. Where pure inductor is there, the current I of t is going to lag V of L by 90 degrees. Here, pure capacitor I of t leads V of C by 90 degrees. Here both are present, so the effect of L and the effect of C gets cancelled, only R remains. If L is more than C, then I of t lags voltage. If L is less than C, I of t leads voltage. Now let's try to represent that in the waveform. This is my V of R resistor, which is given by I into R, and the current in phase with this. This is my I of t lags V of L by 90 degrees, which means this is my VL, which equals to I XL. This is my voltage V of R, which equals to IR, and the current is also in phase. So this is my I. Here I of t leads VC, or VC lags I of t. This is my VC, and this angle is 90 for pure capacitor. This angle is 90 for pure inductor. If it is not pure inductor, if it is not pure capacitor, the angle will be between 0 and 90 degrees. Here we are I of t, VL, VC, where VC equals to IXC. Now we have seen the phase relations between the currents and voltages in RL, RC, RLC circuits. Now let this be voltage across the resistor VR, and this is VL, voltage across the inductor. Similarly, VR and VC. Here VR, VL, VC. Now applying KVL to this circuit, we are going to get the source voltage Vs equals to VR plus VR. This is a phasor sum. Here Vs equals to the phasor sum of VR plus VC. Here Vs equals to the phasor sum of VR plus VL plus VC. I'm drawing a phasor relation or phasor diagram for this. This is my VR. Current I is in phase with VR, so I VL leads I by 90 degrees. Now the phasor sum is, this is my Vs. Magnitude of Vs equals to square root of VR square plus VL square. Theta equals to tan inverse of VL by VR. This is the angle theta, and theta is the angle between Vs and VR, as well as Vs and I. Now for this circuit, to draw a phasor diagram, this is my VR and I is in phase with the VR. VC is going to lag by 90 degrees. Then the phasor sum is, this is my Vs in this case. Now Vs equals to square root of Vr square plus Vc square, and theta equals to tan inverse of Vc by Vr. Theta is the angle between Vs and Vr as well as Vs and I. In this case, draw a phasor diagram. This is my Vr, current I 90 degrees, VL and 90 degrees Vc. The phasor sum is, this is Vs. Vs equals to square root of Vr square plus VL square plus Vc square, and theta equal to tan inverse of XL minus XC divided by R. Now these are the phasor diagrams for different series circuits. For the given circuit, find Vr, VL and theta. So here R is given, that is 100 ohms, and L is given, that is 50 millihenries, and Vs is given, that is 10 volts, 100 Hz. Now we need to find out the Z. Z is given by R plus J XL, where XL equals to 2 pi F L, that is 2 pi, F is 100, L is 50 millihenries. Now if you find this value, 31.42 ohms. Now Z equals to 100 plus J, 31.42 ohms. Now the current I flowing through this is given by voltage by the impedance, that equals to 10 divided by 100 plus J, 31.42, which equals to 10 divided by polar form. If you convert this, 104.8 at an angle of 17.44, 0.095 at an angle of minus 17.44 degrees. Theta is the angle between I and V, 17.44 degrees. Vr equals to Ri, that equals to R is 100, I is 0.095, magnitude only I am considering here, then I will be getting 9.5 volts. VL equals to I XL, 0.095 multiplied by, this is XL, that is 31.42, which equals to 2.98 volts, where given is R equals to 100 ohms and C equals to 50 microfarads. VR is given here 170 and F is given here 50 H. Then let us try to find out the Z, 100 minus J XC. Now XC equals to 1 by 2 pi F of C. Then 1 by 2 pi F is 50 and C is 50 microfarads. Then when you calculate this, you are going to get 63.66 ohms. Then this will be 100 minus 63.66 J, 118.54 at an angle of minus 32.48 degrees. So from which we can say theta equals to 32.48 degrees. The current I is given by, the current flowing through this circuit is constant, or the current flowing through the resistor equals to current flowing through the capacitor equals to current flowing through the entire circuit. So current flowing through the circuit is given by the voltage across the resistor divided by the resistance, that equals to 170 divided by resistance is 100, which is nothing but 1.7 amps. Vc equals to I XC, that is 1.7 multiplied by 63.66, which equals to 108.22 volts. Source voltage Vs equals to square root of Vr square plus Vc square, which equals to square root of 170 square plus 108.22 whole square, that equals to 201.5 volts. Now for the given RLC circuit, find theta, Vr, VL, Vc. Now given R equals to 10 ohms, L equals to 0.5 henries and C equals to 10 microfarads and Vs equals to 50, F equals to 50 H, XL equals to 2 pi F L, that equals to 2 pi, F is 50 and L is 0.5, which equals to 157 ohms. Now XC equals to 1 by 2 pi FC, that is equal to 1 by 2 pi into 50 into 10 microfarads, so 10 to the power of 6 here. 318.5 ohms. Now the impedance Z is given by resistance 10 plus J XL minus XC. So 157 minus 318.5. This equals to 10 minus J 161.5 ohms. Now here the capacitor is having more value than the inductor. So capacitive reactance, that is XC, dominates XL. Z magnitude is equal to square root of 10 square plus 161.5 whole square, which equals to 161.8 ohms. Now the current I is given by, that is Vs divided by the Z. Then Vs is 50 volts divided by Z is 161.8 ohms. That equals to 0.3 amps. Now VR equals to I into R, that is 0.3 into 10 ohms, that equals to 3 volts. VL equals to I XL, that equals 0.3 into 157, that equals to 47.1 volt. VC equals to I XC, that equals to 0.3 into 318.5, that equals to 95.55 volts. Now phase angle theta equals to tan inverse of XL minus XC divided by R, that equals to tan inverse of minus 161.5. R is 10. This value equals to minus 86.45 degrees. This is our phase angle.